So, hopefully you are here for CS140. If not, you can leave as those two gentlemen just did. My name is Brad Vanderzanden, and I have taught this course probably about a dozen times in the past. I tend to have a somewhat different approach than some of the other professors to teaching it. So I will sometimes use a hybrid lecture slash flipped classroom. So sometimes in the class I will actually have you work exercises or small programming problems because research shows that if I just lecture to you for an hour and 15 minutes, that most of you will be goners by about the 20-minute mark, leaving me to drone on for about 55 minutes. So it is better if I do some lecturing, then try to get you involved with some kind of exercise that covers the topic. Then we come back, discuss it, do a little more lecture, so on and so forth. Now, that's not always the case. Sometimes I do have to lecture for the full hour and 15 minutes. The material is sufficiently complex that I just need all of that time. But I do try to mix it up. You can pretty much find everything you need at this website. Of course, unless you have incredibly good vision, you probably cannot see that right now. So let me, wow. And even here, if you have incredibly good vision, you might be a little bit out of luck. So let's pump up that font size a little bit. Somehow 18 point just doesn't showing up quite as well as it might otherwise. We got 24 point there, and that's not going to help right now, but it should help. There we go. Okay, so here is the website for the course. You can also go at the department keeps a list of the course websites, so it's also listed there, but it's a good thing to bookmark. And got that down? Yep. So what we have there is the course information, the lecture notes, the Piazza discussion board, pointer to the labs, practice problems if you ever want to get more practice with coding. Sometimes students ask for that. Guide to past exams, although they're not posted yet. TA contact information. This also isn't, I've got a link to it. I still need to put it up. So that pretty much is all the information you'll need. Now, there is something on Canvas that you might also need, and that would be called the course textbook. So hopefully, actually I'm going to have you all do it now if you have not done it. If you go to Canvas and, well, oh my gosh. Okay, there's going to be a lot of buzzing because we are now doing two-factor identification. So, it's okay if your phones go off for a moment. I'd kind of like you to check it if you haven't already checked it. So you should see Zybooks in your Canvas. Yes?
Yeah.
Excellent. And you should be able to click through and get to the electronic textbook for the course. That's my other course I'm teaching, so obviously you won't see that one.
Yeah, the link doesn't work on mine either.
JSON error. The instructor has not yet configured this link.
Really? Okay. That is not something I'm supposed to have to do. So I'm not going to try to troubleshoot. I'm going to get in touch with the folks at the library, at the Ball Books, and see what that problem is, because that shouldn't be happening. So that's good to know. Can I see what the error message looks like?
Here.
Error. Okay. Okay, I will get that. I'll figure out after, I have a class immediately after that. After that, I will figure out what needs to be done to allow you to access the textbook and send out some message. This is sufficiently important that I will do it on Canvas. I'll also do it on Piazza, which I will talk about. So once we get that fixed, let me tell you about the ebook. It is short and punchy. So it's not long-winded like the textbooks that you are used to. It's basically bam, 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 here's the essential facts, and here's some examples. Now, it also has what are called participation activities. So if we go back to my home page and we go to my lecture notes, you'll see that on every day I have an assigned reading from the textbook, and then I have something called participation activities. If you go, I know you can't do it right now, but I can at least. So for today, the assignment says 8.4 and 9.2. So if I go to 8.4, it's errors and warnings. And you will see that it has little interactive things that you can do. And it has these participation activities, which are essentially like just short quizzes that basically make sure you're reading and comprehending what you have been reading. And research shows that when you're forced to actively engage with the material, active participation as opposed to passive participation, you learn the material better. So I assign these participation activities, and they are due 10 minutes before class. So they're due at 11 o'clock each day, including today, and you all just lost buku points because you can't get to Canvas. I'm kidding. The first one today isn't due until Tuesday. So Tuesday is like a double thing. You do both days and Tuesdays. Yes.
I think you could access the Zybook if you go to modules, and then under the pre-class participatory activities, and just click on the lecture. It takes you there.
Yeah, it's the same for me now.
Really? So go to modules and then go to pre-class. Okay. Thank you. That's a workaround. I need to get that should not be.
And that's got like a direct link to 8.4.
Yes, that's because that's the assignment for the day.
And you can click two other ones. Like you can read the whole entire book from there. Just click
Okay.
next.
So, okay. Well, that's good. I'm glad at least we have some way for. Thank you so much. So at least we got it directly through. But I will still try to get the main link fixed so that you don't have to. It feels a little jury-rigged that you have to go through the link. So that's the next thing is you will find the links to the pre-class activities on Canvas. Please go through the Canvas link. If you don't, it doesn't show up in the Canvas book. It shows up in Zyante, which is the company that publishes the ebook. And I can look at it through a spreadsheet, and I can fix it, but that's a pain in the neck, okay? I'd much rather that you go through the link and do it that way, because then it will automatically be recorded, okay? You can correct your answers. There's no reason you shouldn't get 100 out of 100 on it, because if you mess up, So just randomly, I will mess it up. So I'll just select no error. Incorrect. Statement ends with a semicolon, not a period. So it even tells you why you're wrong. So you can fix it. Okay? So this isn't meant to be high stakes testing. It's just meant to test your knowledge of things as you're going through. And like I said, it's short, it's punchy, it's not long-winded, but I really like it. Students seem to like it. They have animated figures, which is nice. So instead of just looking at a static figure, so here you can start, and it actually runs the, you can see a little animation. Now, obviously, this isn't the greatest animation ever, but the point is, later on, when you get to things like trees or lists or things that involve some moving parts, the animated figures are pretty cool. Okay, so that's the textbook. Then there's also what are called challenge activities, which I don't believe there are any for the first class, no. But there are challenge activities, so you'll see during and after class challenge activities. So remember I said I like a flipped classroom. So oftentimes during class I will have you work on one or more of the challenge activities that are in the textbook. And those are generally short programming problems. So the participation activities are just multiple choice, true, false, maybe some matching, maybe what is code reading. The challenge activities are a little more substantial coding. Okay? They're like short homework assignments. So I have you doing some of those during class, some of them after class. They're due 48 hours after class. Okay? And the rationale for that is, again, research shows if you review material shortly after you have been presented with it, you are much more likely to learn it than, say, if you wait until the exam to review it. So the challenge activities, they don't take that long. They're due within 48 hours. And again, if you go to Canvas, you will find that there is also a module for during and after class activities. You'll also see there's none for today. Lecture 2 isn't until next Tuesday, and then that's January 14th, and you can see they're due January 16th. Again, right before class. So, and if you look here, you'll see that today's lecture and Tuesday's lecture, the pre-class participation activities are both due on the 14th. Okay? So, as I said, I've had a lot of good feedback with the books. I think they're very nice. So, it forces the participation activities are meant to force you to read the material before you come to class so that you're better prepared when you're here. Okay. So, as you can see, this is all if you go to lecture notes. So you get the date, the topics. Now, you will be taking Dr. Plank for 302 next semester. And I follow his labs and his notes so that you are accustomed to his style. So there's also online notes which are supposed to further help you with the material for that day. They can get to be sometimes a bit complicated. So if before class you try reading them and they seem a little bit over your head, don't worry, because oftentimes we go through those online notes in class. So what I want you reading definitely before class is the textbook and doing the participation activities. The online notes are meant to further enhance your understanding, give you some deeper dive into it, because like I said, the book's short and punchy. The notes more verbose, more a deep dive into the material. Okay, and then I record the lectures. So they are normally available about by that evening. So that is provided everything goes well with the Camtasia software, which it normally does. What you see here are links to previous year's lectures. So for whatever reason it doesn't record, I just leave the link to the previous year's lecture, but otherwise I update it with the current lecture. So if you miss class, no big worries on that because you can see the lecture online, okay? Or something goes wrong and you don't understand something from lecture, you can go back and review it. So questions about that? Okay. So course information, we got my information here. Now I actually retired in August, so I am a professor emeritus, making me an itinerant these days. So my office is MinCal 217, which most of you will recognize as the student organization area. So nice place, round tables. I will be there Tuesdays from 3:30 to 4:45 and Thursdays from 2 to 3. I guess one thing I did want to ask is who cannot make 2 to 3 office hours? Is there anyone here who can't make? Okay, so in that case I will also keep the Tuesday 3:30 to 4:45 office hours. That's my email. I prefer just personal things on the email, like I can't make the exam because of X. If you have questions about the labs or the like, I would rather you go to the course discussion board, which is Piazza. Get to that in a moment. You already know about the textbook. Just so you know that I wasn't blowing smoke at you about the fact that you tune out after about 20 minutes of lecture. That's the average adult attention span. You can go to this Harvard meta study and actually read about what I told you. And furthermore, when I first did this in CS102, this is no longer several years ago, this is 10 years ago, the grades in the course when I went to a flipped classroom, they increased by roughly half to 2/3 of a letter grade. So at any rate, you can look at that. Now, what you all probably care a lot about, here's the grading for the course. Got 3 midterms, and they are worth half the grade in the class. You can see the third midterm's not worth as much as the last midterm. You might wonder why. Well, I'm not giving it in the final exam period, I'm giving it on the last day of class. University doesn't let me give you something that's more than 10% in the last week. But also the way it's organized, actually, the first 2 midterms actually cover 2/5 of the material, and the last midterm only covers 1/5, so it also works out that way. Your lab participation, 5%, so that means you actually complete the assigned activity in the first hour of the lab, and that you also do the challenge activity problems. Whoops, I'm sorry. No, that's in the lab. Then the participatory activities, I give you an incentive to do it by making them 5% of the grade, and the challenge activities, also 5% of the grade. Absolutely no reason that this shouldn't be 10% in the bank. As I said, if you get it wrong, you can correct it. So this should be effectively a free letter grade for you. Okay, don't let that opportunity slip away. Okay, then we have, by the way, lab attendance is mandatory. If you missed it yesterday, don't worry. That's not a big deal. But starting next week, there's a little attendance quiz every day. You can't miss it unless you're just willfully stubborn. The quiz is true, false. It says, I attended lab. The answer, as you might imagine, is true. If you want to be willfully stubborn about it and say false, well, then you will not get credit for attending lab that day. So attendance mandatory in the labs. The labs are worth 35% of your grade. Okay. And should you miss an exam without a valid excuse, you will receive an average for the remaining grades. Don't think that and a one-letter grade, reduction. So please don't actually miss exams thinking, well, I'm not prepared, and Dr. van der Zanden says, I will receive an average for the remaining exams. You will, but your grade will go down by a letter grade. Now, if you have a valid excuse, that's different. You break your leg the day of the exam, not an issue. You got the flu, please don't give it to the rest of us. This is one time when giving is not something that we really appreciate. Okay. Class goals. So we are, my goodness. C++, not C+ programmers. Somehow I must have knocked off a plus when I was editing it. Okay, so you went from C++ in 140 to C in 130. You are back to C++ in 140. Welcome to a little bit of schizophrenia. I doubt it will be much of a problem to get back on the bandwagon. So you've already learned most of the language specifics of C++. In this course, you get a couple new things, the big ones being pointers and recursion. So those are two big language constructs that you have not yet seen. We also want you to learn how to compile from the command line, although I believe in 130 you did that. Yes,
Just
no?
single files.
Single files, right. Initially in this course, you'll also compile single files, then you'll go to multiple files later in the course. So another important thing, a lot of you probably didn't get a lot of experience debugging programs in 102. I think that's super important, and 4 of the lab activities are devoted to giving you practice with debugging. Because, you know the old adage, give a person a fish, you feed them for the day, teach them how to fish, they'll be fed for a lifetime. It's the same thing with debugging a program. You go to a TA or to me, we show you what the bug is, we feed you for that particular bug, but if we teach you how to debug a program and you learn how to do it, you'll be much more resilient, especially when we're not around. So becoming more self-sufficient C++ programmers, first goal of the course. Then, what's the name of the course? Data structures and algorithms. So number 2, understand the basic data structures for organizing and efficiently searching data. And we are interested in 3 operations in this course. This course is essentially about these 3 operations: insert, delete, and find into a dynamic set of data, meaning data that can grow and shrink. Okay? These are the fundamental operations of computer science. Think of Google. It inserts stuff into its immense search database. You do lots of find operations on it. Occasionally, it has to delete stuff from its database. Okay? This is the essence of computer science, these 3 operations. And being able to do them efficiently is of prime importance. So in this course, we look at 3 different data structures: hash tables, linked lists, and trees that provide these 3 operations. They have, each of those 3 data structures will have their advantages and their disadvantages. So there's times when you'll want to use each of the 3. And we want you, first of all, to be familiar with these data structures, and secondly, be able to select the appropriate one. Okay. Third thing, we want you to be able to understand basic algorithm analysis. We want you to write efficient code. Okay, we want you to be able to write code such that your programs run as fast as possible. But in order to do that, we have to have a way of analyzing the runtime. We call that algorithm analysis. Okay, it's basically about counting the number of instructions that your program will execute, and that gives us a rough estimate of the running time. So we have two programs, A and B. A executes 1 million instructions, B executes 10 million instructions. Which program do you think we prefer? A, unless you're a hardware manufacturer, in which case B is pretty good. Okay, yeah, A's better. So the point is being able to look at how fast your program is running, seeing where the so-called hotspots are. Hotspots are where a lot of the action is going on, and trying to make those hotspots more efficient. And you'll be introduced to something that we call big O notation, which gives us a rough characterization of the running time of an algorithm. Don't worry about that just now, but this is the second important aspect of the course. It's not just enough to know about the data structures, but we want to know what are the running times of these operations, because that makes a big difference as to which data structure we're going to choose. Okay. And finally, we want you to become familiar with using command line tools. Now, in the past, we were much more heavily oriented toward visual editors in 102 and 130. We have been progressively going back more toward command line tools in 102 and 130, so I believe you're a little more familiar these days with it. In fact, I'm kind of curious, when you did the lab yesterday with VI or a text editing tool of your choice, had you already kind of done that in 130 or 102? Okay, that's good feedback. So hopefully that was quite easy. But you will get, let's say, much more familiar with these command line tools in this course. So questions about our goals for the course. Now, if you want a rough breakdown of how things go, let's just go back to the lecture notes for a moment. We start out and we kind of are reviewing through the end of January your knowledge of C++. So you haven't actually programmed in C++ for about a year. So we find that it's a little bit of catch up. You have to get back up to speed. Plus we go into more depth on things. So the first month may seem like review, but we also do go into new material as well on each of them. Then, starting in early February, we start getting into the data structures. Plus, you see a brief introduction to Big O, which is algorithm analysis. But then, starting in February, we get into the data structures, and we do it fairly quickly, hashing, lists, and sets and maps. So for about a month, we're introducing you to the data structures and how to use them, the API, okay, Application Programmer Interface. The last 2 months of the course, March and April, we're interested in how they actually get implemented, the underlying data structures. So this being computer science, even though in the real world you may not actually implement them, most of the time you'll use predefined classes for them from the standard template library, you still should have an idea of how they're implemented in case you ever have to do it from scratch. So we show you how to implement linked lists and trees, and in doing so you get introduced to pointers in middle of February, and recursion toward the end of March, right after spring break. Okay, and I have to tell you, both of these will give you problems for the most part. So when we get to them, you will probably, those will be the two worst parts of the course for you. I just know from previous experience. So you just accept that that will be like that at the time, and that everyone else is in the same position as you are, that you have not suddenly become stupid, but that these are hard topics, pointers and recursion. You will eventually become comfortable with them, I hope. Not necessarily in this course, but you will see them a lot in 302 and the like. You will get comfortable with them, okay? But many of you will also struggle with them initially, and that's not bad. Okay? So questions about that? Oh, yes.
It's not really about that, but
That's fine.
the dates on that and the Canvas site don't match up. Like for midterm 1, on this it says February 20th, but on Canvas
Yeah, so how is it that midterm 1 is even showing on Canvas? Ah, because even though I did not publish the module, here, let me help you with that.
Yeah. Now, while we're on the
I did, so the answer is,
You missed one.
thank you. I thought that they were not yet published and that I had time to update those dates. The dates on the lecture notes are correct. Okay. Just a second. Let me get to your question in a moment. Let me finish this. So the true dates for the midterms are, in fact, February 20th, March 31st, and April 23rd. Okay? And I give the coding questions for midterms 1 and 2 are given in lab. So in fact, the coding questions for midterm 1 are either the day before or after. I forget whether that's a Tuesday or a Thursday. But basically, the Wednesday of that week, the first hour of lab, you're doing the coding questions. And I use a tool that is no longer, that you haven't seen yet, called Code Assessor. It's an online tool, lets you type in the program and test it. Actually, don't expect you to get it right. Just because you type it in, I don't have to read your handwriting. Big win for me. Hey. Also, it allows me to give comments a lot easier because I just type in comments. And third, it allows you to test the program if you get it finished. As I said, you can still get partial credit even if it doesn't work. It has test data, but at any rate, that's something we'll get to closer to the exams. For the time being, you just need to know that the coding questions are given during the lab section of that week. Then you get more of the conceptual problems on the in-class exam. On the final one, the coding questions will actually be on paper with the exam, and the reason is you need to get comfortable with writing out answers to coding questions on paper because you'll do that in 302. So questions about midterms? Okay, the sample exams aren't up yet. You don't need to worry about them for a while. John.
Okay. Now, trying to go back over to the Canvas page here, actually.
Okay.
You mentioned something about the lab participations.
Mm-hmm. That's attendance, basically.
Yeah.
It's making sure that you have, but the TAs will also check that you've done whatever the lab activity was.
Well, there's this one lab participation. Let's see here. August 22nd, I believe it is.
Where?
2022. For some odd reason, there's actually this one participation here that I think is included for Lab 0. It's only shown on my laptop if you want to have a look.
How about after class? Because
Yeah, okay.
it's not on my Canvas. So, anyone else have an August 22nd participation? Yeah.
It says it's in past assignments.
Pardon?
It says it's in past assignments.
Okay. Well, I'll get that out of there. Thanks. Not showing. Well, don't worry about it. I will.
Yeah, I'll show you later.
Yeah, because I am not
Oh,
finding.
there it is.
820.
Ah, there it is.
Yeah. And for some odd reason, the thing wasn't coming out during the lab. Well, are we supposed to have something like this?
No.
Not yet, at least.
Right, that's what I said. I did not count participation yesterday.
Okay,
So I don't start until 1:15.
got it.
Okay? So thanks for pointing that out because I did not see that. Okay. Other questions? Okay, your lab submissions, by the way, will be on Canvas, and the TAs will probably go over that next week. Okay, so when you submit your labs, they are on Canvas, but if you're looking for where the labs are, they are here. And all the information you need to know about things like late labs, how to submit, blah, blah, blah. Basically, so pointers to the labs, what is the in-lab activity for that day? So the first hour is always some activity. Second hour, you're working on the lab and the TAs are giving you helpful instructions about what to do. When you see these due dates, don't be deceived. They are really the day before because look at the thing, 6 a.m. I know a lot of you are night owls and like to work through the night. So when you see that they're due on Monday, January 13th, they're really due Sunday evening, January 12th, but you're allowed to work on it through the night if you want. Obviously, you're not going to get a whole lot of help when you're doing that. I wouldn't recommend putting it off to the last moment, but I've gotten, again, good feedback. A lot of students like the fact that they can work late. But like I said, when you see these due dates, mentally move them back one day. They're really due the evening before, effectively. Okay, most of the labs are due right before the next lab because I want you focusing on the next lab. At the very end of the course with recursion, one of the labs is a little bit more complicated, and so the very end of the course, the due date switched to Saturday, but that's just at the very end of the course. You essentially get a free lab, so the labs in total are worth 1,300 points. I grade them out of 1,200, so you can actually get positive. You could end up with about 110, 111% on the labs, and that will pull up your grade. So please don't say, can I make up a lab? The answer is you have a built-in lab, okay? You really bomb a lab, it's no big deal because it will still count toward the points. And then late submissions, you can submit up to 3 days late. Each day that you're late is 10 points off. So you submit 1 day late, max you can get is 90 points. 2 days late, the max you can get is 80 points. 3 days late, the max you can get is 70 points. So 10-point deduction for each day you're late up to 3 days late. And you are not to work with other people on it. Let's see. Lab attendance, late labs, there we go. It's okay to talk about the labs with your friends. Once you start coding, best thing to do is to go off and do it separately. Because if you're sitting there working together, inevitably your code looks alike, and there's no way to disentangle it, and we basically have to have a plagiarism meeting then, and I don't like that. So it can range from me giving you a 0 for that lab to, if I'm really ticked off about it, referring it to student conduct. Please don't do it. Do your own work. Don't look on the internet for it. We've had people go out before and look at the internet or engage someone's services, and guess what? There's unscrupulous people who do the same work twice. And so once 2 students paid for the same submission and failed the course. So please don't do it. Okay. Lab attendance mandatory. How your labs are graded. So Dr. Plank has scripts, and 80% of your grade is correctness. We just run a script with 100 test cases. And however many test cases you pass, that's your correctness score. You get 70 out of 100, that's 70 points. 70 times 80 is 56, so 56 points would be your correctness grade for the, you'd get 56 points for correctness. The scripts are available before you hand it in. Okay, we'll go over them in lab next Wednesday. So you know when you hand it in how much you're getting for correctness. Okay, it's no secret. That's why the scripts are there. Then 20% for commenting and programming style. How well the programs are organized, how easy they are to read. This is like your English papers. You write a sloppy paper that's hard to read with crummy variable names, my peeve, you will get points docked. You write something well organized, a delight to read, nicely commented, meaningful variable names, you'll get the full 20. Okay, and there's something on commenting and programming style. Feel free to read them. One by Dr. Plank, one by me, one by former professor here, Dr. Parker, and all of them quite good, giving you some good comments on how to write nice, clean code. Okay, big thing is how to get lab help, because much as we would like our programs to be perfect, they're not. Even our 10-line programs end up sometimes with needing assistance. So, how you can get help. You can visit me during my office hours or make an appointment. You can visit the TAs. I actually said programming clinic, but I believe I told them to hold their office hours in 217. So we'll get that squared away. But we are going to be posting a calendar with all of the TA hours here. And there's going to be a lot of them. I believe we have roughly 20 TA office hours. So, and they were asked to bunch them in the Monday and Tuesday time slots and on Friday for later in the semester. So they're generally, the only day there won't be TA office hours is on Wednesday. That's because of the labs. So we will get this link up, and you can find the TA office hours. It's just at the bottom of the course webpage. Okay, and then the final way to get lab help is by posting a question to Piazza. So Piazza is the discussion board for the class. Have you all used Piazza before? Okay, excellent. So I prefer that you post your questions to Piazza. The reason is severalfold. First of all, that gives me and all the TAs the ability to look at it. So you're going to get a faster turnaround time because it becomes whoever looks at Piazza first, and we have 4 TAs for the class plus me. So that's 5. Whereas if you send an email, that depends on when the person looks at the email and in what mood they are, whether they actually have time at that point to look at it. So post for that reason to Piazza. The second reason is it allows the TAs and me to give you consistent feedback. So if you post a question and let's say instead one of you sends email to me and another sends an email to Clara, who's our head TA, and we give you different responses, that's not good. But if you post to Piazza, the responses will be consistent. because we will all see it. So that's the second reason. And then third thing is, well, it means I don't have to figure out, I don't have to answer the same question 5 different times. Because usually if one student has a question, 10 other students have the same question. And therefore, before you send a question, it's good to look at Piazza because it may already have been answered. If you are posting code, please make it a private post. One of the best ways to get your code plagiarized is to post it to Piazza and make it visible to everyone. Okay, so don't do that. Make it a private post for instructors only. If you do post code to Piazza, I've told the TAs I'm not a big fan of debugging stuff online. I'd much prefer you do it in office hours because you learn a lot more, but obviously sometimes you're working late at night or on the weekends, and you can't get to office hours right then because there's none available. When you do post it, try to be, first of all, post the entire program. Don't just post a code fragment because you might think the error is in that code fragment. It often is not. It's often somewhere else. So we'll look at the code fragment and say, it's fine. Can we see the rest of your code? Save us that problem. Just post all of your code. Again, make it private. Second thing is, if it is failing and it's failing on a specific test case, don't just say this code doesn't work. Try to give us some information such as it doesn't compile or it's failing on test case 10. Okay? Give us a little insight about under what circumstances it's failing. Not just this doesn't work, can you see what's wrong? Okay, because that doesn't really help us a lot. Yes?
With the test cases that we can run through, does it say like what the inputs it's giving our program?
Yes, so the TAs will go through it next week. You can look at, there's files where it shows you what the input is, what the output should be, and what your output is. So it actually runs the program both against a correct program that produces the correct output and against your program, and you can see the two. And in fact, not only, so you can always run, if you have any doubt ever about what output should look like, how it should be formatted, what error messages should look like, there is a perfect program, meaning that is already compiled. You can give it any inputs you want and see what the outputs look like. So the first thing we often say is if you're saying, I'm not sure what the output should look like, is run it with the executable you've been provided. Okay? Because Dr. Plank doesn't tell you what the error messages are supposed to be. So you have to figure out from his output what the error messages should be. And his rationale for that is he really wants you to figure out what the possible error conditions are. So if he tells you in advance exactly what the error messages should be, he's told you what the possible errors are. So it's this chicken and egg problem, right? If we tell you exactly what the error messages should read, then we've told you exactly what the error cases are. And a big thing in computer science is when you're in the real world, no one tells you what the error cases are. No one tells you how the hacker is trying to attack your program. You have to figure that out for yourself. So that's why I know it'll be frustrating because when we test your labs using scripts, it has to be perfect. Your output has to exactly match Dr. Plank's output. So you forget a space, they won't match. Okay, so that's the frustrating part. But the good part is you know exactly in advance what the test cases are. Okay, so I believe yesterday in lab, they made you sign up for Piazza, yes?
Yeah.
Good, I like nodding heads, okay. I think that pretty much does it. just so that you can't miss it, the exam's also here, and this is where it tells you on the 19th and the 1st of April in lab, the coding portion will be. I think that does it for the class intro. Any questions? Okay, at some point later in the class, I may make attendance mandatory here. The first month, I probably won't make attendance mandatory because I don't want to bore you all to tears. By the way, I still have some things to say, so we're not letting you go. I won't make attendance mandatory the first month. After that, I might make attendance mandatory because I find that if you are in class, you are much more likely to get the material than if you're not. And I understand that I post lectures. It still seems to be the case if you show up in class. Part of it is, remember, I flip the classroom. I make you do stuff in class. And sad to say, I know, but if you're watching the video lectures in the comfort of your own room, you're less likely to do those exercises. Okay, you'll just skip ahead. One thing about those video lectures. Don't bother to listen to me at normal speed. Listen to me at a 50% speed up. Okay, again, research shows that we don't talk fast enough. Okay, you can actually, this was a surprising finding, but generally you can speed up someone to about 1.5 times, and that is about the pace at which you want to hear someone. So YouTube, which is where the videos are posted, gives you the option of speeding someone up. So consider speeding me up by 50%, and the lectures go down from an hour 15 minutes to 50 minutes. That's a bonus. Okay. So I don't believe we had any questions. Like I said, we'll get the TA office hours posted, and also I know there's right now a contradiction. One place I said Mingal 217, the other I said they'd be in programming clinic. We'll get that squared away. Okay. Now, thankfully, the first thing you probably have already oops, I did not want that. So today was supposed to be about compiling and learning Unix. It seems like most of you already have a good idea about it. If you need tutorials and you haven't seen these before, Dr. Plank suggests this particular link for the Unix tutorial. And somewhere he also has a suggestion for VI. A game involving VI, huh? I thought, pardon?
Probably called, I think it's called Vim Adventures.
Yes, Vim Adventures is the name. So I will actually Google it all for you. So there it is, Vim Adventures. So it's supposed to, in a game-like setting, help you learn how to use the Vim editor, which is the editor Dr. Plank prefers. I'm agnostic. I tend to use VI or Vim or Emacs, so it is up to you what you use. Okay. So beginning in the class, we will be going with just single files. Later we will get to multiple files. So you're all familiar already with A.out? Yes, no?
That's a first for me.
First for you, okay. Well, in that case, we will kind of cover that. So you're going to be putting your files in files with an extension .cpp. Okay? Get used to putting them in with an extension of .cpp. If you're using Macs, you are going to have to download Xcode. Probably you've already done that. If you're on a Windows box, you're going to have to download something else. And I think somewhere
It was up by the Vim stuff.
it was up by the Vim stuff. Good.
Yeah, Sigwin.
Yep, Sigwin is what we want you to download. Let's see if you are on. It's not in here. Okay, Sigwin, S-I-G here. Let me. This is the package, Sigwin, we would like you to use if you're on a Windows box.
Yeah, I think it's CY.
It's CY.
Oh, CY. Used to be. Let's get it. Sigwin, is that it?
There might also be one called SIG.
Huh.
The website just says,
Yep, looks like it is Sigwin. Okay. So Sigwin is what we want you to use. And you should give you a G++ compiler with that. You're free to use something else. That's just the lab staff recommendation. Okay. So once you've done that, you'll be able to open a window. In the Mac, you can open a terminal window. So hopefully went through this in lab. I don't have to do this now. Yes? Okay. So you open the terminal window, and you will have a command called G++, which allows you to compile a file. When you compile a file like that, it doesn't know what to name it, so it names it a.out. Okay, you might wonder why. It was developed at Unix. The person who developed it decided that that would be what he named it, a.out. If you compile another file, it will overwrite a.out, thus clobbering your compilation of homework.cpp. So, not so cool, right? Because you can only then have one executable in your directory. Does anyone know what the answer is? -O. So you're allowed to name the executable with the -O option. So if you say G++-O, no space there, but a space here, you can name the executable. You want something that is going to make you possibly unhappy. Got something there, excellent. So, this happiness. Blah, blah. Once it gets through, this bad. Okay, saying name my object file foo.cpp. LD can't link with a main executable file. I think this one actually caught it without clobbering the file, but it did not. This makes you very unhappy if you have not backed up your file and you've just spent 3 hours working on it. Okay, so don't switch it. There's no warning. There's just this nasty little error message, and your file has disappeared. Okay, so the -O says I want to name my executable that, and then after that is the file you want to compile. Here, it thought you want it to name the executable foo.cpp, and you want it to compile that. It found it couldn't compile that, and in the process, it wiped out your source code. Okay, so don't try this at home with anything you care about. Okay, you will see, I don't know whether you have seen, these are the things that you're just going to have to get used to. If you want to delete something, it's RM for remove. If you want to list the contents of a directory, it is ls. Okay, if you want to do a long listing, it is ls-l. Do you know how to do y'all know how to read this or not? Okay, you do. Excellent. And then if you want to execute your executable, you can't just type the name of the executable, you have to type /. The dot says I want to execute in the current directory. What if I had said // here? It would look in the parent directory. Okay, so I often still make this mistake because old versions of Unix allowed you to just type the executable name and it would work. These days you have to put the directory in front of it. The easiest way to do that, // Okay, so you probably already know this, but I will reiterate it. Compiler error messages typically cascade in horrible ways. So here is a homework, very short code. It's missing a, right here, it's missing a quote, double quote. See that? There should be a double quote there. Okay, and if you compile this on our Hydra machines, it's relatively short and sweet. You get a missing terminating character. It actually is pretty good about telling you that it's at line 6, character position 11, and then error return was not declared in the scope. And you're thinking, what the? Of course return was declared in the scope. What are you talking about? So, what's the moral here? Correct the first compiler error that you see and then recompile. And then other error messages, like this stupid error message here, goes away. Because it's just basically once the compiler has not seen this terminating character, the compiler gets confused and it starts printing out a lot of nonsense after that. If you try to fix the nonsense after that, you're just going to scratch your head. Like return, you don't declare return. It's a keyword, okay? So, but if you put the double parentheses there and you recompile, the thing will work perfectly. So fix the first error you see and then don't worry about all the other garbage. Here's the same. Look at that. For one missing double quote, a literal manual about what you did wrong, okay? With the first 2 lines meaning something and everything after that being nonsense, okay? So, something goes wrong, fix the first line. Only the first few lines of your compiler output are meaningful. The rest of it is garbage. Ignore it. Fix the first one, recompile. Okay? So that's the takeaway message right there. Look at the first few lines, ignore the rest. Okay? Let's see. One other thing. I am going to take this program and I'm going to do one last thing to it. Okay, I am going to put the semicolon back in. I am going to have it also call a function foo. I'm not declaring foo, I'm just calling foo. Okay. Use of undeclared identifier. Here, let's declare it. Okay. So this is a little bit different. You're seeing undefined symbols for architecture, blah, foo reference from, LD, symbols not found for this architecture. Okay. G++ is actually two things. It is a compiler and what is called a linker loader. In this particular case, the compile portion succeeded. Then it tried to, here, let me show you the process. There we go. Yeah, tell me about it. It's like, yeah, I am. I think it's here. There we go. So we have a source. It goes into a compiler. It comes out as an object file. And that is what you see as .o. The object file then gets fed into what is called a linker/loader to create your executable. In this case, it survived. If we look here, I think we should see. No, we didn't. I'm surprised. But if we do, let's just do this. Anyone know what the -C option does? It compiles it without creating an executable. It only creates a .o file. This failed. This succeeded. Okay? This said compile it, but don't create an executable. Just create the object file, the .o file. So now if I look, notice that there's a .o file. Okay, now I could compile this into, so now when I do it and I provide an object file, it's invoking what is called the linker loader. This is where the error occurs in the loader. It's trying to find a function declaration for foo, and it can't find it. So when you see LD, symbols not found, what it's saying is it can't find a function definition. Okay? And you might say, well, why didn't it complain in the compile stage? Does anyone know why the compiler doesn't bark about it?
It's valid.
It is valid,
You gave
and
it a declaration, it's expecting it.
and
to
I
be
gave it a
another
declaration.
file.
right. What it's doing is, as you get to bigger programs, you don't put everything in one file. You put things in multiple files. So the compiler is saying, okay, cool, you declared it. I suspect that you have this function in a second file that you're going to include later on. Now, when you go to compile it and you don't provide that second file, now the loader goes, whoa, there's no declaration here. You made me a promise and you broke your promise, so why don't you go out and write a foo file function for me? Okay? So, that's the other takeaway, is that when you compile using G++ all the way like this, you are actually telling it to invoke first the compiler, generate a .o file, then invoke a linker loader that's going to find all the function definitions and link them in, load them in, and then you get an executable. If you use the -C option, it will only invoke the compiler and it will leave you with a .o file. Okay? So later on that will be useful. Okay, that's it for today. Remember that for Tuesday, you need to do the participation activities for both the January 9th and the January 14th lectures. I will try to get that Ziante link fixed, and I will see you Tuesday. Just a second. One last thing.